happy to have the chance to speak with you. I'm going to have to speak in English because I don't know Indonesian. So if you need me to talk slower, maybe you'll tell me, or if someone needs help with translating, maybe you can help with the translation. Yeah. They asked that I talk about STEM education, and STEM education is very popular in the United States. It's expanding. It's in the news media a lot. I work at a university that has a STEM center, and we train teachers to teach STEM. So I'm going to use the word STEM a lot. Do you all know what that means? S equals science, yeah, technology, engineering, and mathematics. Okay. Have you ever heard of STEAM with an A? S-T-E-A-M. STEAM. Do you know what the A stands for? Because we also do STEAM education in the United States. A is for art. So STEAM means that you're adding art into STEM. And that's a good thing to do for young children, yeah, because they like to do arts and crafts. So you're teaching STEM, but using art. We also have something called STREAM. Yeah, STREAM. So S-T-R-E-A-M. Can you guess what the R is in STREAM? Did I hear something over here? Yes. I should say, don't be afraid to talk. I'm not too scary, I hope. You can ask questions, and it's okay. Maybe I'm not as formal. Maybe I'm not as formal as a normal classroom, so we have a discussion today. Yeah, okay. Well, the R stands for religion. Religion. So some of the schools in the United States that are private religious schools, they'll integrate religion into teaching about STEM as well. So, right, but we're just going to talk about STEM today. Thank you. Okay. I just want to, this will just be probably about 20-25 minutes to introduce things, and then you'll do your activity. So the U.S. has put out a lot of STEM government reports that talk about what we should do to encourage children and young people to go into STEM fields. And there is a concern that not enough people are choosing science and engineering as a career, and so we won't have enough people to build things and to be the scientists. So STEM education receives a lot of government money. These are just some examples of the reports that are on the internet that you can read about them. And it includes also training teachers. There's a lot of government money going into training teachers to teach these fields in science. So there's a feeling that understanding STEM, and I'm going to talk about how we define STEM in a little bit, but there's a feeling that understanding STEM is important for being successful as in your career, but then also just as a citizen. When we think about making decisions in our lives about things like conserving water or choices that you make, if you have an understanding of STEM, that can help you. Okay, we're in just a minute, we're going to do a very small activity. This is something called the Draw a Scientist test. All right. And this is a way for teachers to assess what their students think about scientists and engineers and mathematicians. So it's a type of test you could do with your students, and you ask them, just draw a scientist for me on a piece of paper. And then you can see what they think a scientist looks like, right? Yeah, and you can do it as a pre and a post. So you can ask them at the beginning of the year to draw a scientist or an engineer or whatever it might be, and then you can do it at the end of the year to see if they've changed their thinking of what a scientist is. So these are some research results from a study that two studies that had children draw scientists, and these are probably grades 7 and 8. And so what do you think of do you see some things that are the same between all three? Like, what do these children think a scientist looks like? A little fuzzy, yeah. Well, do you notice that they're all men? They're all men, yeah. So they were just asked to draw a scientist. Do you notice that they have glasses? Glasses? They all have glasses? Yeah. When children think about a scientist, they think of a chemist, right? Because they're all in the chemistry lab. You see the little test tubes, beaker, right? And then what else is happening? As you move from here, this is just a scientist and he seems safe. But what happens here? There's an explosion. So maybe he's not so safe with his chemicals. And then this is an even worse explosion. His hair has gone back. It exploded in his face. All right. So this is what children think. And these are children in the United States, but this test has been done all over the world. All right. So what does a mathematician look like? You can also do this with your students at the beginning of the year and ask them to draw a picture of a mathematician. So I'm going to ask you, could you take your sheet of paper and please draw a picture of what you think a mathematician looks like. Please take 5 minutes. 5 minutes. You are not going to be assessed. No one's going to give you a grade, so just draw what you think.
Itu matematikawan menurutku kayak gimana? Terus digambar. Iya, gambar aja sebisamu pokoknya.
Matematika hati yang kamu cintai.
Matematikawan sekarang. Tangannya piye? Aku nggak bisa bikin tangan. Juga usah di.
Finish in 1 minute.
Kenapa tahu? Enak gambar. Everyday.
Bangun datar, bangun ruang.
Apa ya?
Would you be willing to tell me what your drawing looks like? Is there anyone willing to share? You don't have to show me your drawing. You don't have to show it to me, but was it a man or a woman? How many drew a man? How many? Man? 6 men? Only 6 drew a man? Okay, yeah. Everyone else drew a woman as a thing to do in your classroom, and drawing or using your hands while you're learning is a good thing for your brain, actually. Like you actually can pay attention better if you add in like moving your hands while you're listening. So, all right, so I'm going to show you, okay, so this is a picture from a grade 7 student in the United Kingdom. And this student drew this mathematician, and then this is what the student said. Very unstylish. A graduate student, and then these are high school students here who are in our program. And then these are pretty young students, yeah? Like 4 years old, 5 years old, and they're working with robots. You know, they're coding, they're doing programming of robots, yeah. And these are our staff. So we do any age level, yeah. And then these are some examples of the topics, right? And then we have a place that's like a library. And I don't know if any universities have that here, but it would be a good thing to maybe think about doing. Yeah. And so at our university, we train teachers, and then our teachers graduate, but they can come back and borrow materials from us for their school, in case their school doesn't have materials. Yeah. And so, for example, we have things like this. This is called a Pico wind turbine. Pico meaning very small. Pico, like nano, Pico. Yeah, right? Because a real wind turbine is really big. Yeah, so this is Pico, really small, and they can change the blades and learn about math and how to create energy. And then we have books of curriculum. So it's like a library for teaching STEM, including mathematics. Okay, so what is STEM? All right, so you've heard the acronym, and I talked about different types of acronyms. This is one of, in my opinion, is one of the best pictures of what STEM is. So it's the connection, right? So it's the connection of all of the four disciplines together. So connecting all 4 of these to solve a problem. And so a STEM activity is a problem-solving activity, but not like what you would do in mathematics necessarily. It's often that you're designing something. And that's actually what we're going to do today. We're going to design something, and then we'll talk about why it's a STEM activity. Can you think of very big problems in the world that require that you use science and engineering and math all together? Can you think of very big problems in the world today? You need to translate? connecting.
Ya pokoknya yang hubungan ini sampai kertas yang dibuka.
Well, okay, I'll just go ahead. What about if you wanted to send a rocket ship to Mars? Right, so, and people are working on that now, sending to Mars. So you have to understand the mathematics to determine how to get there, right, the trajectory. You have to build the rocket ship and design it, so that's engineering. You have to develop technology that will keep humans alive in Mars, on the surface of Mars. And of course, you have to understand the science of what is the atmosphere of Mars, what is the soil of Mars. So very big problems actually require this integration. And so I think what we want to teach students is, as they're learning mathematics, they should be thinking about applications of mathematics. How do you use mathematics in everyday life? So I say that all of these very big problems, many of them require STEM. These are the United Nations Sustainable Development Goals, and look at some of these problems. Good health, right? No poverty, information and infrastructure, clean oceans is here somewhere, energy for everyone. So all of these problems require this integrated thinking, connected thinking about everything. So when you're teaching math, I actually think math is the best subject for teaching about applied concepts, because you need math in everything. Okay, and then the other thing when we're doing STEM education is that we're trying to build these skills in our students. So not just that they learn the concepts, not just that they learn knowledge, but also that they learn creativity. And then also we're trying to build in our students that they're open to ideas, new ideas, that they have a strong work ethic, I'm not sure how to say that in Indonesian, and that they're confident. And then we also, STEM involves teamwork, right? So working in a group. Because if you go out into the work world, you have to be able to work as a group. So these are the kinds of things that we want students to develop, not just that they learn math or STEM, but that they also are leaders, that they can work with others in groups, right? Kind of chaos everywhere. The problems that the students are doing, there might not be an answer to. All right, so open-ended problems. It's okay to fail and try again. And that's very hard for students. Sometimes they really don't like failing or admitting mistakes. So they have to be open to failure. And then it's very important that the students persist, that they keep trying. That's a term, do you have that term, grit? Grit? Yeah, so that's what we would call persistence or grit. So the students that become most successful, or people that can become most successful, they keep trying over and over again, even if they fail. Yeah. Okay, so here we're going to do an activity. It's going to be a group activity, so you're in 8 groups of 6. And I'm going to demonstrate what you're going to work on, and then you're going to spend time working on it. All right. Put them 25 centimeters apart, so you need to move. Oh no, that's closer. Actually, a little bit back. Back towards you. More, even. Okay. All right. Then your design activity, your goal for your design is you're going to build a bridge across here. All right. And you're going to build a bridge using 1 sheet of paper. Okay, just 1 sheet of paper. You're going to build the bridge 4 times, but you're only going to use 1 sheet of paper. All right, so I'm going to put this paper on here, and we're going to build a bridge, right? Oh, not so good. Oh, I just realized I need to show a video. Is it possible that I get to the internet? Alright, we're gonna show it just one more time, but I want you to know that the water is very shallow. No one was injured. No one was, well, maybe minor, but no one died, no one was hurt. Okay. Started at the beginning. Here we go. Okay. Oh, so what happened? Why did the bridge collapse? Pardon? Sorry, I can't. Why did it collapse? Too many people, right? Too much weight. Yeah, not strong enough. Okay. So if you were doing an activity like this with your students, you could show something like this and then have a conversation, a discussion with them about the importance of building strong bridges and good design, right? And then they understand the real world context for what they're doing. Yeah. Okay. All right. So you can as many of these as possible. As many of these are, yeah, like, I don't know how to describe it. All right, so you're going to build a bridge across here, and you're going to try it 4 times, but you're just going to try it 2 times to start. Each group is going to do it, and you're going to design the bridge, and then you're going to record how many of these you can add onto your bridge. All right, and then you're going to do it like this. So you'll make your bridge, and then you'll add 1, and then 2, and you'll keep adding until your bridge collapses, just like the Chinese video. Yeah. Oh, what's happening? A landslide now. 4. Are you going to keep adding? And then if your bridge holds all of these, then you're going to come back to the side, and you're going to start adding even more. You're going to stack them. Okay. And so over here, each group, once you try it once, try 1 time, and then you're gonna draw the shape of your bridge, and then a number of whatever those are. More. Okay. So every group. Maybe we can put the number of the group on the table. Yeah. So all right. So do it once. And see if you can, and see how many of those you can add, and then once you've done it once, do it a second time and see if you can improve it. Yeah, okay? All right, so here are the rules. Only 1 sheet of paper. You can only use 1 sheet of paper. Oh, do we have the tape? Okay.
Bagaimana caranya biar nggak cantik?
Okay. So you need to record. So come over here.
Satu ya. Tapi jangan kasih, ada jatuh.
I'm just gonna borrow some.
Sampai jatuh. Harus sampai jatuh.
Sampai jatuh.
Sampai jatuh, dicoba pinjam itu.
Pinjam murnya, ditambahi terus murnya sampai dia jatuh. Berapa kali dia jatuh?
Bella, kamu naik di situ lah aku. Yang mau saya.
Very good. Okay, so up there, draw the shape, cross section, right? So like this. This is your cross section, kind of like this. Oh, like this. Put the shape up there, and then you had 21. Yeah. Okay. All right. Then you need to try and make more than 21. Try it again. Improve your design. More than 21. I'll find you some more. You probably need some more weight. Is this your number one bridge? First bridge? Yeah.
Ini nanti balikin ke sebelah. Katanya ini dicoba jalan dulu satu-satu. Maksudnya
Coba bikin lagi model yang lain. Bikin tuh jangan cuma satu jembatan lah ya. Jembatan lain. Di mana murnya? Murnya tadi kalau antri itu.
Alright, how many can you
Kita harus ketemu ya. Apa tinggal di sana ya?
And you have the number, then come up here and put your bridge design, and then the number that it was able to hold, the number of objects. And then if you finished it, then work on a second design, and so try to get more the second time. Try to make the bridge stronger the second time. All right, so right now there are only 2 people, and then we don't have enough of the objects.
Oh, okay. That's it. Yeah. And right up here, put your number. Count. Oh, tadi berapa?
Masih
Yeah,
satu.
okay. When you add it, you've been adding it this way, one at a time. 1, 2, 3. I think it's okay. Actually, can you show me again? Yeah, show me again. Go ahead and try again. Okay, so yeah, good. You're creasing it. Yeah. Okay, so then 1. Yeah. Okay. No, no. Only from one side. Like people walking. It's a strong bridge. No.
Bilangnya kan gue sempat bro.
Maju alun-alun.
Oh. New bridge.
New. Gaweannya.
Ah.
Nusa.
Huh?
Very strong.
It's very strong. You need some more. Okay, we need you to borrow some.
Berapa? 27. 7.
Ada lagi nggak?
If it falls off, then you have to start again. All right,
The term is metacognition. Have you heard that term, metacognition? You can do the activity, but then you must have a discussion so that your students can understand what's happening. Okay, so look over here. Well, first of all, let me ask, for those of you groups that did 2 bridges, was your second bridge stronger than your first bridge? Yes. Very good. Yay. Anyone else? Anyone no? No? Yes? No? No? Okay. All right. All right. Now let's look at the class data so far. All right. So some of you have, okay. So the first one, right? We've got some that just have done 1 and some that have only done 2. But what shapes have the strongest design? Looking at these shapes.
Mana yang punya desain mana yang membuat paling kuat?
No. You must only come from one side. No? Okay, now start there. Yeah. Is it saggy?
Are they going to teach grade 7, 8, high school, junior high? You're going to teach elementary school?
Middle school.
Senior high school and middle school. Okay, okay. So, it's a very simple activity, but what it teaches is some of the idea. It teaches the idea that's very important in STEM, which is the idea of the design process, and I'll show you that in a minute. But so when you do something like this, and there are other activities, you can ask your students some questions, and I'm just curious for you in particular. Like, are there things that you would do differently, or would you like different materials other than paper? Would you like? Can you think of other materials that you would have liked to have had instead of paper? Yeah. Go ahead.
Apakah kalian bisa menggunakan material lain selain kertas?
Like, do you have foil, like tin foil?
Mungkin seperti aluminium foil itu.
Yeah.
Ada yang lain mungkin selain aluminium foil dan kertas.
So you could test with different types of materials. You could test, right? Yeah. Okay, so as a teacher, or may I ask a different question? As a student, if you're a student, what's good about this activity for students?
Kegunaannya apa ini buat siswa?
Maybe one at a time? Yeah.
Maybe one of you.
Yeah.
By this thing, I think the children will improve their creativity or make the innovation.
Very nice. Yeah.
Someone else say something about why it's good activity for students? No one?
Ada lagi?
Working in groups with,
Ada masalah bekerja dalam kelompok?
no disagreements.
Tidak ada ini kecocokan gitu.
Ikan mur.
Some, yeah, maybe. All right, so then you plan your bridge, then you create your bridge, and then you work to improve it. So the design process is a cycle. And so STEM education, it's not just building, right? But then you have to improve. You test, you build, you test, you improve over time. And so these are the kind of steps that goes into it. Because is it bad if it's loud? Is that a problem? Yes or no? Yeah. No. All right. It's good. I mean, when we heard the sort of when someone's bridge collapsed and everyone goes, oh, right? That means they're enjoying. Okay, good timing. I think if the children are noisy, it means they're enjoying what they're learning, and if they enjoy math, that's a good thing. So being loud is okay. One thing that you can do, that we do, is we ask the students to set the rules for how they will behave in their classroom. So it's not the teacher asking, but the students. So the students might say, so if I were to ask you, what kind of classroom do you want to learn in? You might say, other students should listen when their classmate is talking. You might say, no cell phones while we're doing an activity. So the students set what we would call the norms of the classroom. You want to
seperti ini. Siswa itu kalau tidak ramai itu tidak belajar. Jadi kalau kalian ingin siswa kalian tidak ramai, sebaiknya kalian membuat suatu aturan sehingga yang harus ditaati oleh siswa kalian.
And we write it on a board, right? And so then if another student isn't following the rules, then the other students will tell them, right? Yeah.
Jadi aturannya itu ditulis di papan tulis. Jadi ketika teman kalian itu melakukan suatu kesalahan, maka kalian harus saling mengingatkan seperti itu.
Yeah.
Is there any question here?
Oke, di antara 5 ini siapa yang sudah siap badannya ya? Oke, Sulistina, Yazidul Khair, Nurul Izzah, Faizatin, Lufi, silakan. Sulistina mana Sulistina? Ya.
Assessing, yeah.
Yeah, that's a very complicated question. Yeah, there's can I say 2 things? So just in the same as here in the United States in math classroom, the curriculum is very full and very focused on the test, right? So it's hard for teachers to find time to implement it. We often have STEM clubs after school, yeah, and then we also have like activities that they can do in a community center or on a non-school day. For assessing STEM, yeah, that's a little difficult, but you are looking for changes in their designs, like for this one, right? So you could ask them to write in a journal their decision process. How did they design the building? So sort of see if they're learning the design process, their decision process. That's one thing that we do. So journal. So it's more qualitative. Yeah.
So there are no like question like I don't like to assess it. Except journal.
Right. Just a few. Yeah, there are very few. No, it's most of the questions, item assessments are where you might be given. Yeah, it's more about career interests, and yeah, not so much. I haven't seen very much on actually STEM content and how to assess it. We usually have to do it using, qualitative rather than items. Yeah. So it's a little hard. Yeah, but you could think about, for this one. It's a hard question. Sorry. Yeah.
Okay, the other student want to ask question.